We are going to start on 11.3 today, which is adding and subtracting radicals. So just like if I had variables, 6x plus 2x, I would add the coefficients. So I add this 6 and the 2, and I keep the same variable. If I have something like 3 times the square root of 2 plus 5 times the square root of 2, I treat this radical as though it were a variable. So I just work with the coefficients, the 3 and the 5. I add those and I keep the same radical. I cannot combine those because I'm not multiplying, so it stays as that same radical, 8 times the square root of 2. Let's go ahead and try one of the examples from your book. If I have 5 times the square root of 7 minus 6 times the square root of 7, this square root of 7 stays the same, so I'd keep it as though it were a variable at the end, and I'm just saying 5 minus 6, so I'd actually have a negative 1, and just like with a variable, I don't have to have that 1 there. I could just say the negative square root of 7. If I have square root of 2 plus 3 times the square root of 2 plus 4 times the square root of 2x. Now, if I have something like this, I'm going to work with what gives me the same radical symbol. So in this case, I have the square root of 2 and 3 times the square root of 2. I treat this as though there's a 1 there. It's the same exact thing. So I'm saying 1 plus 3 is 4 times the square root of 2. This right here cannot be combined with it because it has an x in the radical symbol. Just like combining like terms, it has to be exactly the same. So I'd keep that as 4 times 2, the square root of 2x. So there is our simplified version. Now let's say I have something like this. The square root of 12 plus the square root of 27. It does not look like I can combine them because there are no like terms, but I do know that each of those have factors that go into them that are perfect squares. So let's go ahead and separate that. The square root of 12 would be the square root of 4 times the square root of 3, because 4 times 3 is 12. Bring down my plus sign, and 27, the square root of 9, and the square root of 3, because 9 times 3 equals 27. So now I'm working with that product property. I can take the square root of 4, which is 2. The square root of 3 has to stay the same because 3 is a prime number, so I cannot take a square root of it. The square root of 9 is 3. And again, I keep that square root of 3 in the radical symbol. Now I'm looking at what we were just doing, where I have like terms, and I'm going to work with the coefficients. So 2 plus 3 is 5 times the square root of 3. I keep that as a radical. It does not change. It just becomes a like term that I can combine. And that's my simplified version of this right here. Now let's say I have something like this. I'm going to go ahead and look at 54. I know that I have 2 and 27, 3 and 18. I'm going to go with 6 and 9. I know that's a perfect square, so we'll go ahead and try that. The square root of 9 times the square root of 6. And then with 24, I believe that 4 is the only perfect square, but let's go ahead and double check. There we go. Okay, so we have square root of 4 times the square root of 6. So this right here is where I still have radical symbols in both of my products. I haven't simplified them yet. So 9 times 6 is 54. 4 times 6 is 24. Now I can simplify. The square root of 9 is 3. Bring down that square root of 6. The square root of 4 is 2. Bring down that square root of 6. Bring down my plus sign. Now I'm saying 3 plus 2 is 5. And my radical stays the same. There's my simplified version. Let's say we make it a little bit harder though. And I have 4 times the square root of 27 minus the square root of 18. These are examples from your book still. And 27 we did a second ago. So I still want to keep this coefficient here. And then I know I have the square root of 9 and the square root of 3. And with 18, I have the square root of 9 and the square root of 2. So now I'm saying 4 times the square root of 9 is 3. Keep that other 3 right here in the radical symbol. Square root of 9 is 3. Bring down the square root of 2. Now I have another step here because I had a coefficient to start with. So 4 times 3 is 12. I have 12 times the square root of 3 minus 3 times the square root of 2. I don't have like terms, so this is as simplified as it can get. I cannot combine these two terms because they do not have the same radical symbol. All right, that's as hard as it's going to get. So here's your assignment, 11.3. It's going to be on page 713 and 714. You're going to do 2 through 38 even. I would definitely suggest trying this before we have our Zoom call toward the end of the week so that we can go through some of these answers, because I know some of them will be a little bit harder to simplify than others. So good luck.